All right, in this lecture, we're going to talk more about these bonds, these connections between atoms. So specifically, there's actually three kinds of bonds that exist. Bonds can either be non-polar covalent, polar covalent, or ionic. So we're going to learn what's the difference between these kinds of bonds. And the reason why this is important is eventually we're going to hear that depending on the kind of bond, it affects the properties of the molecule. So the way that we determine what kind of bond we have in a molecule is we use something called electronegativity. So let me tell you a little bit about electronegativity. So electronegativity is really just how strongly atoms are attracted to shared electrons. How strongly are atoms attracted to shared electrons? So basically, every number is given, or every element is given a number. So the numbers you can see on this table here, they go from like 0 to 4. The biggest number you'll see is 4. So every element is assigned a value. And the way this works is the higher the value, the more you love shared electrons. So something with the value of 4, they do love electrons. If you have a value lower, like 0 or closer to 0, you don't love electrons. You don't love electrons, shared electrons. So you can see there's kind of some arrows. There's a general trend here. Basically, as you go across the periodic table, things like electrons more, and as you go up. So the most electronegative elements are like fluorine and so on in this top corner. All right. So we're going to use this fact to try to figure out when electrons are being shared between atoms, who likes them more? And whoever likes them more, that's where the electrons are going to get gravitate towards. They're going to move towards the atom that likes them more. All right, so with that, let's talk about these different kinds of bonds. All right, so let me flip over and we'll look at a little chart. All right, so again, there's three kinds of bonds: non-polar covalent, polar covalent, and ionic. The difference between these kinds of bonds really is electrons can be shared equally. If they're shared equally, that's called a nonpolar bond. If electrons are shared unequally, that's called a polar covalent bond. And then the last kind of bond is called an ionic bond. And in an ionic bond, they're not actually shared at all. Like one atom is just taking them from the other atom. So electrons are not shared, they're transferred. So how do you know what kind of bond you have? Well, the way you know is you basically look up the electronegativities and you see how far apart they are. So generally, if you have, and instead of writing electronegativities, that's a lot of letters, I'm just going to write EN. If you have an electronegativity difference between two atoms of 0 to 0.4, that's a nonpolar bond. If we look at the two atoms and the electronegativities are 0.5 all the way up to 2 apart from each other, that kind of difference would go with a polar bond. And then if the electronegativities are way different, and by way different I mean more than 2, that is called an ionic bond. That'll be an ionic bond. All right? So let's look at an example of each. So an example of a nonpolar bond would be a bond between carbon and bromine. If I look up those electronegativities, carbon has a value of 2.5, bromine is 2.8. So if I look at those two numbers and I subtract them, the difference is 0.3. So that basically means both of these atoms like shared electrons roughly the same. So that means the electrons aren't going to get pulled towards one atom or the other. The atoms like these shared electrons roughly the same. Now, that's not always going to be the case. Let's say we had a bond between carbon and oxygen. And if I look up their electronegativities, I'm going to erase these, we get, what? 2.5 for carbon still, and 3.5 for oxygen. So now there's a bit of a difference. If I subtract, you would get a difference of 1. And by the way, just so you know, when you subtract, you always take the absolute value. You have to have a positive difference. So the difference is 1 unit. So that tells me that these electrons are not shared quite evenly. One atom likes the electrons more than the other. To be specific, the guy who likes the electrons the most is the guy with the bigger value. So the electrons are going to get pulled towards the oxygen. Why oxygen? Because it has the higher number. So there's a couple ways we could show that. One way is you might see someone draw an arrow with a little cross on the sign. And that's supposed to show you which way the electrons are going. They're going towards oxygen. Oxygen is going to like them more, so they're going to move towards oxygen. And when that happens, again, that's called a polar bond. The other way I could show you this idea is instead of drawing an arrow, I could use a symbol to say, hey, the electrons are going towards oxygen. So that area is going to become a little bit negative. So that's a Greek letter. It's like a Greek D. It's called delta, and you see a delta minus. So it looks kind of like a D with a little squiggle on the top. So wherever the electrons go, they bring negativity with them. So they're going to make the oxygen a little bit negative because they're kind of gravitating towards the oxygen. Now, wherever they leave, if you lose electrons, that's the carbon who's losing this battle for electrons, it's going to become slightly positive. So that's one way to tell about these electrons moving. Now, this happens when you have an electronegativity difference somewhere in this range, 0.5 to 2. You subtract the values, you get some in that range, you got a polar bond. Now, ionic bonds are when there's a big difference. So an example of that would be if you have an electronegativity or a bond between like lithium and fluorine. If I look at the electronegativity of lithium, it's 1. And fluorine, I'm going to erase that a little bit. Fluorine has a value of 4. So if I subtract, now the difference is really extreme. It's 3. The difference is 3. So anything above 2, those electrons are going to get shared at all. They're just going to get taken. The fluorine loves them so much more, the fluorine is just going to grab them and take them. So the fluorine would get a negative charge. It's going to take electrons. And lithium, he's losing the battle. He's going to end up with a positive charge. All right, poor guy, he lost electrons. So if the difference is really big, there's no sharing at all. There's just like this transfer of electrons. We've talked about ionic bonding before. All right, one last thing I want to tell you on this slide, and then we'll do a little practice of this, is nonpolar bonds. I should have mentioned this earlier. They're also sometimes called a pure covalent bond. All right, so the goal for this lecture is if you see a bond, can you tell me what kind of bond is it? Equal sharing, unequal sharing, or transfer? Let's do a few examples. All right, let's take a look at this question. It says, which bond is more polar, a carbon-oxygen bond or a fluorine sulfide bond? And show the direction of polarity for both bonds. All right, so what does that mean? Well, when they say which one's more polar, the bond that's going to be more polar is the one where there's a bigger difference in electronegativities. The bigger the difference is, the more uneven that battle over shared electrons is. So let's go ahead and write both of these bonds down, and let's look up their electronegativities. Carbon, 2.5, oxygen, 3.5. Fluorine, 4, sulfur, 2.5. So if I subtract in the carbon-oxygen, the difference would be 1, wouldn't it? Yeah. And then down here, the difference would be 1.5. Keep in mind, we're always taking the absolute value. All right, so they're both polar bonds because they have a difference of more than a half. Which one's more polar? It's going to be the fluoride-sulfur bond. That would be more polar. Bigger difference, more polar. Now to answer the second question, what showed the direction of the polarity? How did that work again? The elements love the fellow with the higher, electrons I should say, love the fellow with the higher electronegativity. So down here, the fluoride would become a little bit negative, the sulfur a little bit positive. In the first one, the electrons love the fellow with the higher electronegativity. Oxygen would be a little negative, carbon would be a little positive. All right, with that, let's have you try one. I can't do everything, can I? You got to do something. All right, one for you to think about. All right, so let's say we had a bond between phosphorus and chlorine. Now, I put up the electronegativities. I don't have the whole thing up, just like kind of a part of the periodic table. So let's imagine there's a bond between phosphorus and chlorine. And I ask you, what kind of bond is that going to be? What kind of bond is that going to be? So think about it for a minute. It could be ionic or covalent. Again, this would be, to be a little more specific, like non-polar covalent is what I meant by that. Or it could be polar with the chlorine with a bit of a positive charge, or it could be polar with the chlorine with a little bit of a negative charge. Which one of those options sounds right? All right, well, let's figure it out. So the way I would know it is, again, I'm going to look at my electronegativities. Phosphorus 2.1, chlorine 3. You subtract them, what'd you get? 0.9, right? So I think what we saw on the previous page was if there's a difference of 0.5 to 2, this is a polar bond, unequal sharing, polar covalent, unequal sharing. Now, if it's unequal sharing, who's winning? The chlorine. So the chlorine, because he's winning, he's going to become a little bit negative. And I think that answers the question, but just to be complete, the phosphorus would become a little bit positive. So the right answer, I think, is D. All right, it would be a polar covalent with the chlorine with a little bit of a negative charge. Unequal sharing, chlorine becomes negative. All right, let's do another one. Let's do another one. All right, the last question for you. It says, which one of these is the most polar bond? Oh, we got 4 choices there. Most polar, what's that mean? Highest difference in electronegativity, biggest difference in electronegativity. Figure it out. Okay, hopefully you got that. With that, that's it for this one. So we got one more part C. We'll get to it in a minute. And it also has to do with polarity, actually.